All right, we're going to take a look at transformations and piecewise functions today. So in the last set of notes, we talked about all of our parent functions. So we want to start out by talking about transformations of those parent functions. Now we're going to be focusing on the main six. We're going to shift up or down, left or right, or reflect over the x-axis or the y-axis. Now we have to know how to recognize these in an equation when we see them. So your function, when it says f of x here, that just means your function, whether it's an absolute value function, a square root function, a quadratic, whatever. So if we have the function and then we have plus something behind it, in this case plus 2, that means it is shifted up 2 units. So we take the original parent function and the entire thing just shifts up 2 units. If you have a function and then you have minus 2 behind it, or minus whatever, then that means it's going to be shifting down however many units. So again, the entire parent function just scoots down 2 units. Then we look at the horizontal shift. So these are vertical shifts, and these are going to be the horizontal shifts. So for horizontal shift, you're going to have something added or subtracted inside of the function. So an example of that would be, let's take the absolute value. If we have the absolute value of x minus 2, so we have x minus 2 inside of the absolute value or the square root or the parentheses or whatever, then that's going to be the absolute value function. And then we're going to take the entire thing and we're going to shift it to the right 2 units. So the whole picture just picks up, moves over 2 units, and plops back down again. Now, for the left, it says plus 2. Now, you should have learned at one point that inside is opposite. So to the left is plus, to the right is minus. So if we've got something inside, let's say y equals, we'll do a quadratic, x plus 2 inside parentheses, and then the squared around it. Then that's going to take that entire parabola, the u, and it's going to shift the entire thing to the left 2 units. So it'll look exactly the same, it'll just be scooted over a little bit. All right, then the last 2 are going to be our reflections, and those are if we have a negative. Now it does depend on where the negative is. If the negative is sitting in front of the function, then it's reflected over the x-axis. If the negative is inside of the function, then it's reflected over the y-axis. So over the x-axis is upside down, and over the y-axis, it is going to reflect or flip left to right. So whatever's on the left side of the y-axis will flip over to the right. Whatever's on the right side of the axis will flip over to the left. Now let's give some examples of what those look like. So let's take a square root. So if we have y equals, and we've got a negative in front of the square root, then that's just going to take that entire square root function and it's going to flip it upside down. So instead of going up like this, it would go down like this. All right, then the next one is over the y-axis. If that negative is inside of the function, like let's say, let's do another square root. If we have y equals, and then inside of the square root we have negative x, then this one is going to shift over the y, or reflect over the y-axis. So instead of going like this, it would flip, and it would now be going more like this. All right, so those are going to be our 6 main transformations. Let's take a look at some examples. So we're going to graph each function using transformations, and then we're going to determine the domain and range. So if we take a look at this first one, we have an absolute value function, which we need to make sure that we know the parent function for. So if we take our parent function and we do our table, and we're not going to do too many points. So for the parent function for absolute value, we know that the absolute value of -2 is +2, absolute value of -1 is +1, absolute value of 0 is 0, absolute value of 1 is 1, and the absolute value of 2 is 2. So remember, we talked about the importance of knowing these parent function points. So if I were to take those points, -2, +2, -1, 1, 0, 0, 1, 1, and 2, 2. And obviously we could continue those points on, but those are those basic parent function points. They give us our nice little V. Now we want to look at what is it that we're supposed to be doing. So we have our parent function, and we're going to go ahead and list that. Parent function is y equals absolute value of x. The only difference between this equation and this equation is that -2, because remember, f of x is the same thing as y equals, so that's not really a difference. The only difference we have is this -2. Well, that -2, since it is behind the function, is going to shift it down. So it is going to shift the parent function down 2 units. All right, so then if we take each one of those points and scoot it down, then this point will now go here. This point will now go here. This one will go here, and then so forth and so on. So we have the exact same V, it's just lower. Oh, try that again. Dang it. Alrighty. Okay, so always, when you're doing this on paper, make sure that I can see your points. Like, I need to actually see these little dots. All right, so there's our new function. Now we want to do the domain and range for this. So the domain, well, since we have arrows going to the left and to the right, that means that it is going left to -infinity forever, and it is going right forever, +infinity. My range, however, the lowest the graph goes is right here at -2. So we have a bracket -2, because it's not an open circle, it's a normal circle, so we use a bracket. But then from there, it is going up forever. Therefore, it goes to infinity. All right, so there is our first transformation. Moving on. All right, the next one we have is a square root function. So let's start with our parent function points there. So the parent function would be y equals the square root of x. And so those parent function points would be 0, 0, because remember, we can't take the square root of a negative number. The square root of 1 is 1. Then we skip down, the square root of 4 is 2, and the square root of 9 is 3. So if we take those parent function points and put them on our graph, we have 0, 0, 1, 1, 4, 2, and 9, 3. Then we look at the difference. So the only difference between this equation and this equation is that +1, and that +1 is behind the function. It is not inside of the square root. If it was inside the square root, then it would continue out like that, but ours does not. Therefore, this is behind the function, and that means that it is going to shift the parent function and this one is going to be up 1 unit. So every one of those parent function points, we're just going to scoot it up 1. So this first one, we go up 1. Then this one goes up 1. Then this one, up 1. And this one, up 1. So then we connect those new points, and we have that square root function, but it is now going to the right from a little bit higher starting point. Now for our domain, the smallest x value we have on this graph is here at 0. So it starts bracket 0, but then it goes forever to the right. Therefore, that is positive infinity. Then for the range, the lowest the new graph goes, the new one, is going to be here at positive 1. So our range begins bracket positive 1, but then it does go up forever from there. It doesn't go up very fast, but it does go up forever. So 1 to infinity. Alrighty, that's number 2. Number 3, we have an absolute value function again. So we know that our parent function will be y equals the absolute value of x, and we know that those parent function points are going to be -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. So we put those on our graph, and we have our little tiny v here, which could go further, but we're just choosing to stop. And then we need to look at the difference between the equations. The only difference between this equation and this equation is this +2. But this time the +2 is inside of the absolute value bars, so we have to remember that this is opposite, which means that that is really going to the left. So this is going to shift the parent function left 2 units. All right, so then we take each one of those points one at a time, shift them each to the left 2. So we take this one and we shift it 1, 2. We take this next one, shift it over 2. Then we take this one, we shift it over 2. Take this one, shift it over 2, which covers an original, but that's okay. Then we take this one and we shift it over 2, and we have that exact same little v, just scooted over. So we've got our new graph. Now we list the domain and range. Well, this is absolute value, and we've already talked about absolute value goes left forever and it goes right forever. Therefore, we've got -infinity to positive infinity. Now for my range, we have to be careful in absolute value of how far down is it going. Well, in this case, it's only going down to 0. Remember, we're looking at the y values. So the lowest y value is 0. So we have bracket 0, but then from there, it goes up forever. So that would be to infinity. Alrighty, so there's number 3. Let's take a look at number 4. We've got a little bit more work here because we have more than one transformation. First of all, we want to think about our parent function. Because of this squared, that tells us it is a quadratic function, and that parent function is going to be y equals x squared. So let's come up with our table for the parent function, and then we'll get that on the graph and figure out how we need to transform it. So for a quadratic, remember we're taking whatever it is, whatever x is, and we're squaring it. So if we take -2 and we square it, we get +4. If we take -1 and square it, we get +1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. So this gives us our parent function. So -2, 1, 2, 3, 4. -1, 1. 0, 0, 1, 1, and 2, 4. So those are my parent function points. And notice that I'm not connecting my parent function points because that's just my beginning. I don't want to connect points until I get to the end, and color coding really does help. Now, if we look at this next one, we have 2 differences. Instead of just having x squared, we have x plus 5 squared. So that means that that plus 5 is inside, and inside is going to be opposite, which means that it is really going to the right. Oh, sorry, that's opposite. To the left, my bad. Okay, so this is going to shift it to the left 5 units. And then we have our -4 behind the function. It's not inside of what's being squared. It's behind what's being squared. Therefore, this is going to shift down 4 units. So we're going to take each one of our parent function points and we're going to shift it left 5 and down 4. So if we take this first one and we count left 1, 2, 3, 4, 5 and down 1, 2, 3, 4. Then we'll take this next point and we're going to count left 5, down 4. So 1, 2, 3, 4, 5, 1, 2, 3, 4. Then we take this point and we count left 5, down 4. Then we'll take this next point and we count left 5, down 4. And then our last one, we take that one and we count left 1, 2, 3, 4, 5, down 1, 2, 3, 4. And so we have that same pattern of points, it's just kind of scooted diagonally down. And then remember, a quadratic should be rounded on the bottom, so that we do the best we can to make that rounded. And there's our new function. Now to get our domain and range, well, our domain, quadratics, go left forever, right forever, and everything in between. So we've got -infinity to +infinity. My range, however, just like with the absolute value, this one is not going down forever. The lowest it is going is a y value of -4. So it is going to begin with a bracket, -4, but then from there it does go up forever. So we do infinity with a parentheses. All right, we are almost done with our transformations. We've got one more to go. And then we'll look at a couple other things. All right, now this one. Again, start with your parent function. We have the absolute value bars, which means that's our parent function. Y equals absolute value of x. And we know those parent function points should make that nice, pretty neat V. So I'm not going to list those again, but we should know what they are. And we can keep those dots going if we want to. So there's our parent function. Now, if we look at this, we have 3 differences. We have a negative, and that negative is in front of the absolute value. It's not inside, it's in front, which means that this is going to reflect over the x-axis. And so let's go ahead and do that. If I take these points and reflect them over the x-axis, all it does is flip them over, upside down. So right now, this point is currently 3 above the x-axis. When I reflect it, that means that it's going to go 3 below the x-axis. So it's going to end up right here. Notice that my x value didn't change. It just went straight down. So this is a distance of 3 right here, which means this should be a distance of 3. Okay, those should match. Then if I take my next point, this one is 2 above the x-axis. So when I reflect it, it should go down to 2 below the x-axis. Then I take this one. Right now it is 1 above the x-axis. When I reflect it over, it should be 1 below the x-axis. Now for this one, my vertex, it is on the x-axis. So if I reflect it over the x-axis, it doesn't change. It just stays the same. Then we take this one, flip it down to 1 below. Then we take our next one and we flip it down to 2 below. And then we take the next one and we flip it down to 3 below. Okay, so that has taken care of the reflection, but that's it. I haven't done anything else. I have to look at what else I have to deal with. I have this -3 that is inside of the function. Therefore, since this is opposite, that means this one is going to shift to the right 3 units. Then I have a plus 5 behind the function, and so that is going to shift it up 5. So now I'm going to take my new pink points. Once I've reflected them, I no longer use these. You can ignore them, or you could even erase them. So if you choose to erase them so you don't have extra stuff, then that can kind of simplify things. If you're doing it in pen, that's not really an option. You have to know to ignore them. But we're going to take those new pink points and we're going to shift them at the same time, right 3 and up 5. So if I take this first point and I shift it right 3, so 1, 2, 3, and up 1, 2, 3, 4, 5. Then we're going to take this next point and we're going to go right 1, 2, 3, up 1, 2, 3, 4, 5. And we've got that one done. Now we take our next one. We go right 3, up 5. Then we take the middle one, the vertex, and we go right 3, up 5. If I do the same thing for the remaining points, the next ones are starting to go down, so we should see that again. So this, if we go right 3, up 5, we get that next point here. Then we take the next point, this one, and we go right 3, up 5, and then we take our last point, right 3, up 5. And so we get this same upside down V, but it's shifted over and up. And so this would be our final graph. Now, when we go to do our domain and range on this one, we need to be careful. The domain, not so tricky. So for my domain, it's going left forever, it's going right forever, it includes everything in between, so we have that nice normal negative infinity to positive infinity. Now the range, however, is where we need to be careful. Remember, interval notation must be from smallest to largest. So the smallest y values are down at the bottom. Well, on the bottom, we are going down forever, which means we are beginning at negative infinity. So down forever is infinity in the negative direction. Then we look at how high it goes. Well, it goes up to a y value of 5. So then this would be 5, and it would end in a bracket. Alrighty, so that gives us that. So be careful of the ones that are flipped upside down, because they very often are going to begin with negative infinity. Alrighty, so now the next one we want to take a graph that they've given us, and we need to come up with the equation. So we need to know, based on the shape of this graph, what kind of function it is. So this is a V. We know V's come from the absolute value. So our parent function would be y equals the absolute value of x. Now, the question is, what have we done to it? Well, we know that the original parent function should be starting here at the origin and then going up like this in both directions. So that means really the only thing they've done is just scoot this whole thing up. They haven't shifted it left or right. It doesn't look like it's wider or skinnier or anything like that. They haven't flipped it upside down. So the only thing they've done is to shift it up. So how far did they shift it up? Well, from 0, the original vertex, it goes up 1, 2, 3, 4, 5. So it goes up 5, and up should be behind the function. So we would have y equals the absolute value of x, but shifted up 5 units. And so that would be our equation. Now, if they wanted in function notation, that simply means that we would do f of x equals the absolute value of x plus 5. Okay, the last thing that we need to do for this set of notes is piecewise functions. And these look very complicated, but they really don't need to be. So piecewise functions are literally just functions in which we piece together parts of more than one function. So we're going to take little pieces of different functions and we're going to stick them together on one graph. Now, we're going to try to make this as simple as we can. For a piecewise function, ours are only going to have two pieces. We're not going to have more than that. Now, we know that f of x means the same thing as y. So instead of f of x equals, I'm going to write y equals. And then I have two pieces. I have a 4x and I have an x plus 2. So I'm going to start there. I'm going to have my y equals 4x, and I'm going to have my y equals x plus 2. So I'm basically just breaking it up into two separate equations. Now, what I'm going to do is I'm going to set up a table for each one of these. So I'm going to have a nice simple xy table. Now, where I have to be careful though is for this first piece, the 4x, it tells us that we can only use x values that are less than 0. Now, it says less than 0. It does not have less than or equal to 0. However, in a piecewise function, we are going to have to go ahead and plug in 0, but because it doesn't have the equal to bar, we know that that first point is going to have to be an open circle. Now from there, we want numbers that are smaller than 0. So smaller than 0 is -1, -2, -3, and I can go as far as I need to, or what fits on my graph. So let's start here, we'll finish this piece, and then we'll move on to the next. So if I'm plugging 0 in for x, then 4 times 0 is 0. Then I'm going to take -1, plug it into that x. So 4 times -1 is -4. Then I'm taking -2. I'm plugging it in for that same x. So 4 times -2 is -8. And that's really all I'm going to be able to fit, because if I do the next one, -3, and I plug it in for this x, then I have 4 times -3 is a -12, and my graph does not go down that far. So it's fine that we put that in our table, we're just not going to be able to graph it. Now, let's plot those points. We said that this first one had to be an open circle because I do not have the equal to bar here. So I'm going to have an open circle at 0, 0. Then the rest are just going to be normal points. So I have a normal point at -1, -4. Then I have a normal point at -2, -8. And that's all that fits on my graph. So from that open circle, I'm going to go down through those other points, and I'm going to put my arrow on the end. So there's the first piece graphed. Now for the second piece, we're doing the y plus 2. So we have y equals x plus 2. Now, we're going to do our table for that as well. So we have x, we have y. Now, for this one, it tells me x is greater than or equal to 0. So we're going to start with the 0, but this time, since we have the equal to bar under it, this one will be a closed circle for that first point. And then, since we want x values that are bigger than 0, then that means we're going to do 1, 2, 3, and so forth. Again, I can go as far as I want to. So then, if I'm plugging in now to this x, so if I plug 0 in there, 0 plus 2 is 2. Then I plug 1 in. 1 plus 2 is 3. Then I plug in 2. 2 plus 2 is 4. Then I plug in 3. 3 plus 2 is 5. So this gives us 4 coordinate points. Now we said that first one has to be a closed, solid circle. So at 0, 2, we have a closed circle, not open like the pink one, closed circle. And then everything else is normal points. So the next normal point is at 1, 3. Then I have a normal point at 2, 4. And then I have a normal point at 3, 5. So then from that closed circle, I go through the other points and then put my arrow on my line. So this is my piecewise function graphed. Notice that there are two pieces of lines on one graph. Now, to determine our domain and range, so for the domain, we need to think about what all the possible x values are. Well, we can simply get that from the problem. So if I get rid of my circles here, for my domain, this tells me that x can be anything smaller than 0. This tells me that x can be equal to 0, and it can be anything bigger than 0. So right there, that tells us that x can be anything. So our domain is going to be negative infinity to positive infinity. Now the range is a little bit trickier. So let's take a look at our range. Now, for the range, we know that we are supposed to go from smallest to largest. Ranges are y values. So y values are smallest on the bottom. So if we look at the bottom of our graph, we've got an arrow that goes down forever. So we're going to start that at negative infinity. Now, we need to be careful from here because we do see that the top goes up forever, which would be positive infinity. However, there is a break in my graph right here. So in between that open circle and that closed circle is a gap where I have no graph. Those are not connected. Therefore, there is a break in my y values. So my first piece goes from negative infinity, and then it goes up, 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 and then stops here. So it stops at a y value of 0. So 0. And then we need to be careful with the symbol. We have an open circle here, which means it is not equal to. Therefore, that 0 should have a parentheses. Now, we've got our break, so everything between 0 and 2 is not represented on our graph. So we're going to have a U, and then we're going to have that second piece. My second piece, the y values, begin here at positive 2. This one is a solid circle, so it's a bracket, positive 2, and then from there, it goes up forever. Therefore, we've got to infinity. And so we've got our domain and our range. All right, so it's kind of a plug and chug, little bits and pieces. None of it is difficult. You just kind of have to watch it and be careful of the little things. So we've got one more piecewise function we're going to do, and then that is it for today. So again, we have two pieces to our function. We're going to start with this one. So that's going to be y equals negative 2x. And we'll go ahead and do our table for that. Now, we have to be careful because this time it's not 0. This time it's negative 2. So negative 2 is going to have to get plugged into both of them. One of them, though, will give us a closed circle, and one will have an open circle in the beginning, based on where we have that equal to and not equal to. So for this first one, we're going to start with negative 2, and then we want numbers that are smaller than negative 2. So that would be negative 3, negative 4, negative 5, as far as we want to go. And this one is equal to. So that means this first point will be a closed circle. So let's go ahead and get this one done and graphed. So if I plug negative 2 in for x, I have negative 2 times negative 2 is a positive 4. Then I plug in negative 3, I get positive 6. Plug in a negative 4, I get positive 8. Plug in negative 5, and negative 2 times negative 5 is a positive 10. All right, so there's the first piece of our function. So we have our closed circle at negative 2, positive 4. Then we have just a normal point at negative 3, 6. And then another one at negative 4, 8. And then another one at negative 5, 10. So from our closed circle, we go up through our points, and we've got our line there for that first piece. All right, first piece is done. Now we go on to the second piece. So this is y equals 2x plus 4. And for this one, we want x values that are bigger than negative 2. Now remember, we still have to plug in the negative 2, but because this one is not equal to, this one is going to start with an open circle. Then from there, from -2, we want values that are bigger than -2. So we can say -1, 0, 1, 2. We probably really don't need to go that far, but that's okay. So then when we plug them in, we are now plugging them into this x. So if we plug in -2, we have 2 times -2, which is a -4, and then -4 plus 4 is 0. Then we plug in -1. So we have 2 times -1, which is -2. Then we add 4, that gives us 2. Then we plug in 0. 2 times 0 is 0, plus 4 is 4. Plug in 1. 2 times 1 is 1. 2 times 1 is 2, plus 4 is 6. And we really probably don't need to go any further. So I want an open circle for the first one on this one because we don't have the equal to bar. So we have -2, 0, and we want an open circle. Then normal points at -1, +2, 0, +4, 1, +6, and we could keep going, but we should get that same pattern. So we've got a line going up from there. All right, so we have our graph. Now let's talk about our domain and range. So for the domain, again, just like on the other one, we have here all the x values that are smaller than -2 and -2 itself. Here we have all the values that are bigger than -2. So again, that includes everything. So our domain would be -infinity to +infinity. My range, however, I've got to be careful on. So for my range, I'm looking for y values, smallest to largest. So the smallest is on the bottom, and this is as far down as our graph goes. It does not go any lower than that. So that has a y value of 0. However, at that point where we have that y value of 0, it is an open circle, which means we need a parentheses on that 0. Then from there, okay, here's another place we need to be careful. We do have a break here between those 2 points. However, we are looking at just y values. So let me kind of try to visualize this for you a little bit better. If I take my horizontal line, so I'm looking at y values. So here we have a y value of 0. Now, can't equal 0, that's fine. So I'm looking for, are these y values included? So if I go here, well, there's +1, that's included. I've got +2, it's included. This is the y values, included. There's 4. Now, I go up here. So really, if even just following the blue piece, I've got everything from 0 up forever is included. So even though there is a break here, the y values are somewhere on the graph, everywhere from here up. So it's a little bit tricky. Just because we see a break doesn't automatically mean we need the u. So everything from 0 up is somewhere on the graph, whether it's on this piece or whether it's on this piece. All those y values from 0 up are included. Whereas up here, when you had that break, there was no graph anywhere in here. Those were left out. Whereas here, those y values are included right in here. So that's why we have a u for this one, and we have just a single for this one. Okay, hopefully that makes sense. And that is the end of our notes for today. And then you guys are just going to work on your homework. All right, I will see you guys next time.